Okay, part 3 of our electrocardiography series, I will introduce how to read the ECG, which will be important for your lab report. So in the introduction.pdf file, they gave you this huge image that is really hard to break down when you're first trying to orient yourself to the various pieces. So I'm going to break it down in a simpler way and kind of highlight the various parts that you're going to need to know about. The first part, and this is some terminology that you're going to need to understand what the lab manual is asking you to do. First is the waves, and as you might expect, these are these two parts here. They say this bigger part, they have a different name for this. So the P and the T waves kind of appear to be at the very beginning and the very ending of this hypothetical electrocardiogram that you're looking at. This middle piece is called the complex. Specifically, it's called the QRS complex. A lot is going on in there, and we'll talk about that in just a few minutes. Now, the next thing that always trips up my students is the segments and the difference between the segments and what comes next. I think it's intervals. Segments are these little pieces of time where there are no waves or complexes happening. So this segment is kind of just this. This is hypothetical. This is a flat line here. Really, in a real electrocardiogram, you're not just going to see a perfect flat line. There's still some waviness going on here, but this is a hypothetical illustration. So when very little is going on, you're in a segment. Same with ST segment. So it's the period of time between waves and complexes, but not including a wave or a complex. Now, intervals are similarly named. You'll note there's a PR interval. There was actually a PR segment as well. Here's our PR segment. They're different things, so don't get them mixed up, because the lab manual is going to ask you probably for identifying some of each. So you have to know your difference. So your PR segment is kind of between the P and R when nothing is going on. Whereas the PR interval is including some of the wave or the complex. So that's very different. This is including the P wave and R in the QRS complex. Now, this is super important. The isoelectric line is this imaginary flat line around which all the movements are happening, the waves and the complexes. This is a really important line. When you're gathering data, if you're wiggling around, say you've got your electrodes hooked up to yourself and you're kind of wiggling and moving, and you're unfortunately, because you're running this on yourself, you're going to be also clicking the mouse. What's going to happen to this otherwise flat isoelectric line is it's going to start waving. So you're going to have to be forced to try to read these waves and complexes, not on a flat line, but on a curving line. So you're going to see waves kind of going at a strange angle, and it's going to make it very hard to gather data. We'll talk a little bit in another segment on how to gather your best data and a lot of the goal of that data is for your isoelectric line to be truly flat and not waving in and of itself. It's usually most prominent right after your T wave and before the next P wave. This is typically where the least amount of activity is going on and where you can see it looks as flat as you could hope it to be. So now tying that into systole and diastole, and that is how you pronounce it every semester. I have people saying systole and diastole because that's phonetically how it looks. But systole, typically, and I think maybe if you watch the YouTube linked videos as well, you would know that when somebody doesn't mention what kind of systole, they're talking about ventricular systole. So again, the atria can also contract and relax, but typically we're not talking about atrial systole, we're talking about ventricular systole and diastole. So systole is that contraction and ejection phase. That's where the ventricles are doing all the pumping and the work. And the diastole is usually relaxing and filling. Another way I've heard it described, which is kind of helpful, is systole is when the heart is beating, and diastole is kind of in between beats. That's a little simplistic, but it gives you a nice mental image of kind of the difference so you can kind of get that square in your mind. Oh, one more thing about systole and diastole, because you're going to have to identify, you're going to have to measure the length of time for systole and diastole in one of your heartbeats that you will have measured in this lab. So you need to be able to identify where does systole begin and where does it end. Systole begins at the peak of the R spike, as this is often called. The very, very peak, right in the middle, you're going to find your point. This is going to be your I-beam cursor. Find it, start in the middle, and highlight to a third of the way down the T wave. That is systole. And then diastole is starting at that third of the way down the T wave and ending at the R spike of the next heartbeat. So together, systole and diastole make up the amount of time between one heartbeat, from one heartbeat to the next. And they're just broken up in different time amounts. Okay, now in terms of the electrical system, the electrical conduction system that we learned about, what are these things representing kind of in the real world? So the P wave is representing the depolarization of the atria. Remember, depolarizing something is getting it ready to go to work. So this is, the electrical signal is telling it get ready to go to work. So we're depolarizing here. At the end of all of it, this is the far end, is the repolarization of the ventricles. So these are what the waves are representing, is one is a depolarization, one is a repolarization of different chambers of the heart. Then in the middle is the complex, and that represents the depolarization of the ventricles and the repolarization of the atria. What you should know about this is really the stronger electrical signal of these two is, you could guess, again, the ventricles are the stronger muscles. The depolarization of the ventricles, that electrical activity is kind of overshadowing the repolarization of the atria. So what you're seeing with the big R spike is really the depolarization of the ventricles. Kind of underneath the surface, the atria are repolarizing. So, trying to put this in chronological order. First, the atria depolarize. Remember, the blood comes to the atria first. So it's atria, then ventricles. And as you know from other classes, Dr. Friedman's class or others, first there's a depolarization, and then there's a repolarization. So the atria first depolarize and repolarize, and then the ventricles then depolarize and repolarize. So to put it all kind of in chronological order, this is kind of laying it out. So remember, atria, the blood reaches the atria first, then the ventricles, and everything things depolarize before they repolarize. This should help you remember the order that everything happens in. Okay, and in the next video, we'll be talking about lab tips.